Alright, here we go again with Newtonian physics. I have the coefficient, or I have the friction of kinetics times acceleration minus mass times the coefficient of static. Underneath that is weight squared, and it's plus n minus f times the coefficient of kinetics plus pi, and equals my golden constant. But there's a little thing wrong with it. I'm not sure if it's spinning on its own or if it's doing its own thing or not, but it could be angular momentum. So what I'm thinking about doing is making it angular momentum, gravitational angular momentum, and calling it the fourth principle in physics, or in Newtonian physics for gravity. So what I'm going to write down now is fourth principle of G. Alright, so let's see if I can show you guys it now. It's too fuzzy. Hold on, I can't zoom in or anything. Well, anyway, I wrote the fourth principle of G. And the reason why I put the fourth principle is because we're not in that dimension. There's the fifth principle, and we're not in that dimension either. But they do pop up in different types of gravitational fields. And it's not the only one that pops up in a gravitational field, but it is one of the golden equations that if you divide it, it is angular momentum that pops up. So let me fix this. Fourth principle of G. Yes. I figured out how I fix this real quick, and you guys can see it. So it's friction of K times acceleration minus mass times the coefficient of static. Underneath that is square root W, and then plus n minus force times the coefficient of kinetics plus pi. Now, I don't know if they knew pi back in the day or if it was a part of Newtonian physics, but it should have been, because then he would have figured a lot more stuff out. So, if I were to put G there, maybe it would work out in my favor, maybe it wouldn't. But what I do know is that it's almost exactly what I have already drawn up in the form of actual physics, American English. So there you have it. Alright, people. See you later.